All right. Well, welcome back, everybody. I'll turn on my webcam for a second here, just to see how that works. Okay, so let's get started. I wanted to first of all mention that there is a homework assignment available now, and it's posted in Blackboard. And so the assignment, let me just bring it up as a Word document so that you can see what it looks like. Watershed modeling. All right. So what we're going to be doing today allows you to complete this assignment, and it's basically that you're going to select a watershed and go through the process of delineating that watershed, adding in some image files in the background, and giving me the statistics on it, like the drainage area, maximum watershed length, that sort of thing. So I think that you'll have all of the skills that you need to complete that assignment, maybe after today's class, but certainly after Friday's. And so that assignment's available now on Blackboard, and I think the due date for that is Monday of next week. So please let me know as you're working through it if you have any questions. I think it should be relatively straightforward. Before we begin, does everybody have the assignment? Does everybody have the software installed? So are there any issues related to installing the software that we need to address before we begin? All right. Now I see that most of you are through Blackboard, and that might have been because you weren't initially able to join in Zoom. I see that there are 2 people in Zoom. The advantage of Zoom compared to Blackboard, I believe, is going to be that you'll be able to see the cursor on Zoom and also in the lecture video, but you're not able to see my cursor when you are joining through Collaborate. And on a software demonstration like this, having a view of the instructor's cursor may be important. So I'm just going to continue to run both of these methods in parallel for the immediate future until it's clear that one approach is better than the other. And of course, I'm recording the lecture video, and that'll be posted on YouTube as per usual. So here's the announcement slide. What we're going to be focusing on today is trying to use WMS in the kind of the first most immediate way that we can to locate a project area of interest. And all right, thanks for letting me know about that, Jeffrey. Let me turn on the sharing screen for Zoom. How about now? Can you see what you need to see in Zoom at this point, Jeffrey? Is the screen being shared now? Zoom has no sound. Okay, let me see. Well, boy, I'm surprised to see that there's no sound on Zoom, because I think I've got everything enabled on this end. So I guess maybe in the short term, Collaborate is going to be our way to go. All right, Jeffrey says he does have sound coming from Zoom. So it might be the speakers that Brandy isn't having the audio for. All right, so we're going to use WMS today on 2 different locations. The 2 locations that we're going to be using it on is Paden City, West Virginia, and on watershed in Huntington, West Virginia. And sometimes one of the difficult things in watershed modeling is just even finding the project that you are trying to be working on. The first site that we're going to try and do, Gamble Run and Payden Fork Road in Payden City, West Virginia. And so open up WMS, and I have to drag it over here to this screen so that we have got it. All right. So if you've already played around with it a little bit, just begin with a new project. So here, File, New, so that we're just kind of starting with a clean slate. Boy, managing two different broadcasts while also recording, I think, is too distracting for me. I'm just going to have to settle on one versus the other. All right, so we have WMS, and what we're also going to need to do is, first of all, use Google Maps to give us an idea of the project location. And the reason for that is usually when you're doing watershed modeling, someone will tell you the watershed or the stream crossing they mean by giving cross streets. And that's one thing that WMS can't do. You can't just type in like a, the intersection of one road and another into WMS and find the watershed that you need. And so you kind of have to begin with an overhead view using a mapping application. And so I think Google Maps is a good way to start with that. So open up a browser tab, and in the search bar, go Payden City, West Virginia. If we zoom out a bit further here, the watershed that we're interested in is on the outside of town. So you can see in, well, maybe you can see my cursor, maybe you can't, but in the center of the screen there is a road that's called 26/2. Do you see 26/2? I'm gradually zooming in on it. And here is what Google Maps is saying. The name of the road is Gable, and then Payden Fork Road. And one of the tricky things is that a lot of the roads around here have different names. Like if you're driving along the road, it may have the county road numbers, it may have the name of a road. If we pan to the side a little bit, you'll know that the name that it's saying here is Gamble Run Road, and actually that's the true name of this road all the way along it is Gamble Run Road. It's just at some point someone did a typo and just wrote Gable on part of it. But the watershed that we're going to be working with is this Payden Fork. It's this watershed that is draining. It's draining the rainfall from the area that is to the south and east of town. So we're going to keep this tab kind of open and in the background to help us identify the crossing we're interested in, because what we in theory want to be able to do is, you see where Payden Fork is going under this Road 14, which is Gamble Run. Let's say, for instance, that somebody wanted us to size the culvert at that project location. We would have to know what watershed is feeding the flow underneath that road. So this is our crossing. This is going to be our location of interest that we do the delineation based on. So switch back to WMS, and we're going to begin the hydrologic modeling wizard. So across the top, you'll notice that there's a series of these icons, and the one that we're going to be using is the wizard hat. But if you hover the cursor over it, it says Hydrologic Modeling Wizard. So click on that, and the first thing that we're going to need to do is define the name of the project. And so just browse to a location. You maybe should create a subfolder that you can use through the rest of the demonstrations that we're going to be doing in class. So I'm going to call this one, it's in my C drive, So Demo Wednesday, I'm going to call it a Payton class demo, and then save here. And it's not yet actually saved. If you look up at the top left side of WMS where it says WMS 11.0 untitled.wms, it's just kind of a strange quirk that you actually have to click on the save button here in the wizard window. And so when I click on the save button now, you'll notice that it is giving me the correct file location and file name across the top. Okay, so we've saved the project. Now on the left side of this wizard is each one of these rows indicates different locations within the wizard kind of structure or process. It's a step-by-step procedure, and so when we click the next button, we're going to be going from the project file name. Next it will be define project bounds. So if you click next, you'll notice that now it's highlighting define project bounds, and we have to define a projection. And so it's saying not defined right now. Click on define, and we're going to switch from no projection, click on global projection instead, and what we're going to select is one of the projections that indicates UTM, Universal Transmercator is what that stands for, and Zone 17 North is the region that West Virginia is within. And so I have this recent projection selected, but most likely since you haven't used the program previously, you don't have something like that already cached inside of the program. So if you go here into expanding the list of projected coordinate systems and scroll down, next we're going to select UTM and scroll down, and we're going to select either NAD 83 or WGS 84. Either one works, and of course those same options are available if we expand the North America option. But WMS does a good job of importing all of the data files that we're going to go out onto the web into the correct projection system once you've specified one. And like, how would you know which of these to select? Most engineering offices is going to have a dedicated GIS guy or lady, and they're going to tell you like what's the typical for your office, you know, whatever data source you're generally using for your projection system, and what's the datum that a lot of their surveying is based on. And so this isn't anything that you'd necessarily be expected to know. You'd just sort of find out what's the office standard and what most projects are using for the projection system. So in our case, let's just today use NAD 83. So we got this under UTM, NAD 83, scroll down to Zone 17 North. And once we click OK, then that's added into the window. And for the vertical datum, instead of having a local vertical datum, we'll use a standardized datum that's been specified, and we'll change it to the most recent vertical datum, NAVD88. And then instead of feet units, we need the units to be in terms of meters. So select meters and OK. And we'll verify that the units are set to meters. Up across the top, there is a spot where it's telling us the horizontal units and also the vertical units. All right, so the projection is set, and now we're going to define the project boundary. Now this is where we may face a couple of computer issues. I'm hoping it's not going to be anything fatal, but when you click on define, it may ask you some question having to do with should you edit the registry, and you just need to approve, and that'll be like a Windows pop-up. That's Windows asking if it's okay to edit the registry. Say yes or accept or approve or whatever the yes answer is to that question. Another tricky thing that sometimes comes up when we are using this tool is that it will go into the background, and so sometimes you just need to click down on the Windows icon at the bottom of the screen. Like if all of a sudden your wizard goes missing, click on that and it may bring it to the forefront again. So click on Project Define Boundary. For me, every time I click it, it's opening over here in my secondary window, and I have to drag it over to the main screen that I'm showing and sharing with you. Mine is already set on Paden City, but yours won't be. It's, for me, set in Paden City because I was looking at this watershed last night. So yours most likely is zoomed out to include the entire world, and it may not be necessarily a street map. I'm not sure what the default is. It may be as topographic. So I'm going to pause for a moment. I'd like everyone to kind of weigh in on, I see 9 students in Blackboard, and I think we've only got 9 students in the class, and so everybody's on Blackboard. Did everybody get the virtual Earth map locator on the screen okay? Let me pause for a moment for you to respond. Just type I got it if you have it, or I don't have it if you don't. Jeffrey's having problems. Now, the thing that we may have to do if you have persistent problems that extend beyond today's class meeting is, we can use Zoom for me to look at your screen and actually take control of your screen. So I might be able to interact with your computer and help you overcome the problems. But, without seeing it, it's tough for me to help you out. So does anybody have the Virtual Earth map locator up? I haven't seen any comments from students yet. Nick says he's got it, but the map is blank. All right, that's okay. We can deal with that for now. Anybody else have the tool up? Brandy has it, but the map is blank. Once we type in a location, it may be blank because it's zoomed in so close. And so let's type in a location here in the search tool. Type Paden City, WV, and jump to search location. And then try toggling between these different map options and see if that doesn't change the view that you've got. I think probably streets would be the most useful for today since we're going to be looking for a cross section. Okay, so Nick has it. Success. All right, so someone else was able to zoom in on Paden City with the same streets view. That's 1 out of the 8 that are remaining. Brandy says that it's frozen somehow, or if maybe it didn't work yet. Well, it's not the sort of thing where the computer generally has to think about it for a long time. It's probably either going to be working or not working. How to get from being blank? Try typing in a location and jump to search location. So it may be blank to begin with because it's just zoomed in really close. Brandy's got it. She refreshed the tab. All right. And sometimes what you may need to do is cancel the tool. Like when in doubt, close it out. So open it up again. Move over here. Brandy suggests to refresh the tab, reselect define. I don't see define anywhere on this. Oh, reselect. I think Brandy's saying that reselect this button right here. Yeah, sometimes you have to close the locator and open it up again, restarting it. So Paden City, West Virginia. Austin has it now. Jeffrey, do you have Paden City brought up in the locator? No response from Jeffrey. Said I was missing files and need to install them. All right, well, we're going to have to try and figure that out together after class. So if you're not able to get it, then you can just observe for this one. Okay, so if I just clicked OK right now, so if I click OK, you'll notice that, oh, Jeffrey says it just finished installing them. That's a good news. So it has these coordinates, and so it's looking at the left coordinate, the lower left, and upper right. So it's defining kind of the bounds of that project, but it wasn't the right project because it's only going to go and get data that is in the view once you click OK. So I need here to zoom in on my watershed. And so you remember that what we were interested in is this intersection of Gamble Run and Paden Fork Road. So this map actually has the correct names for the roads on it. And Google maybe sometimes will have the correct names, sometimes this will. But what we weren't able to do here is say an intersection. So this is the creek that we want to know, what watershed upstream area is feeding the flow in that creek as it goes under Gamble Run Road. Now, here's an important thing. You can kind of get a sense for where the watershed is by the ridge lines that are visible on the screen with the street maps. You can tell from the shading. They do kind of like an artificial shadowing to give you a sense for where are the high points and where are the low points. If I clicked OK right now, Jeffrey asks, how do you jump the location? You type the name in the search tool. So you type in Paden City, WV, and click Jump to Search Location. And then it will take you to the city, but we want to focus in on the contributing watershed. Now, this is one of the pities where it's too bad that you can't see my cursor. I will try and ask Dr. Yoon if he's found a way to illustrate where the cursor is. I asked the IT people earlier this week and they said there wasn't a way. They said that there's a pointer that you can use when you're writing on the screen, but not the program cursor itself. So if he's got a workaround, that's fantastic. So anyways, back to identifying our watershed area. The tricky thing is that we want to make sure that we've got only the area we want and none of the area we don't want. Because if we zoomed out really far, like the watershed I'm interested in, yes, it's inside the window here, but I'd also be downloading tons of elevation and mapping data for other areas. And so the download time and the processing time is going to be enormous. Our project files will be too big. And so it's a good practice to zoom in on just the location that you're interested in. But if you zoom in too close, so like if I zoomed in just on the crossing itself, it's not going to get the elevation data for the entire watershed. It would only get the elevation data for what's in the window. And I know the watershed goes beyond even here. So if you look at the ridge lines, you can sort of see that the watershed extends beyond the screen. Like right now, the upper area of the watershed isn't yet in my full view, and so I have to zoom out a little bit more. Now I have the whole watershed. And you can't see me trace it with a cursor, but you see this Dutch Run Road in the center of the screen there? So that's part of the area that's going to be contributing to the flows at the intersection of Gamble Run and Paden Fork Road. So make sure that you've got about this in your view. And we could maybe zoom in a little bit closer. No, that's too close. I think this is going to be the happy medium. So have this on the screen and then click OK. Let me give you just a moment to make sure that you have about the same area indicated. Okay, so click OK, and now we've got these coordinates in the boundaries, and we click Next to go into watershed data. the first time you use the program, you're going to have to click to enable use web services. And so that probably wasn't enabled the first time, so make sure that it's on yes. That's what tells WMS to go to the servers and download the data. And then this time we're going to get the elevation data. Let's also get the USA topo map. Let's get the world street map and the world imagery, just to see what it does with that and where it puts it. So have those four things selected and then click on download data from web. And when you do, it's going to start loading the data after it asks, like, what resolution do you want things resized to? And if you just click OK every time it asks that, it'll be fine. It's basically looking at how closely zoomed in you are, and it's offering to rescale the images and the elevation data based on the good balance between how long it's going to take to download and the resolution you need to get an accurate idea of where the ridgelines are inside of the watershed. So your network connection may be a bit slower than mine, and so it may still be downloading those data files. Let me pause for a moment. Jeffrey asks, what do I do for the select data sources? I'm not sure if I understand the question. Do you see these four tabs that are ticked? So use web services. So the only thing you have to do on this screen is check the box, use web services. And then you go to next after that. And then click those four tabs and then click download data from the web. Alright, so if we close this, you'll notice on the program screen that here in GIS data we've got a couple of different image files loaded, and they're on top of each other, so we can't initially see them all. If you turn off this elevation TIFF, that's kind of the colored map. It's the heat map that gives you an idea of the low points and the high points, and if we turn that off, then what it's going to do is allow us to see the next one that's in order here, which is the topographic map. And topo maps are put out by the USGS. You can see that it's kind of just like a rough view of the city. If I turn off up here under terrain data, these contour lines that the program has generated based on the elevation data file that it obtained can be enabled or disabled, and they correspond pretty closely to the topo map. You'll notice that the topo map, this is basically just an image file, and so the projection system is working good. WMS is importing all of the maps at the correct scale and on top of each other. So depending on what we want to look for, we can enable and disable those. And here's Gamble Run Road. If you look at the image, you can see the name of the road that we're looking for, Gamble Run and Payden Fork, and so kind of the intersection of those two is what we're going to be focusing in on when we delineate the watershed. So let's turn off the topo map and then click off, and this time it's showing us the street map. So this is similar to what we had seen when we were in the locate project area view. And then if you turn that off, the last kind of mapping that's available is the aerial photo. Now we can zoom in on the location that we're interested in, and when you zoom in, on the left hand side under GIS data it says processing, because it's trying to rescale that map to kind of like improve the quality of it as you're zooming in. But we have a sense for our project location. If you turn just the elevation on, and let's go with the street map. Alright, so Gamble Run and Payden Fork Run. Open the wizard tool back up again, the hydrologic modeling wizard with the icon at the top of the screen, and select the Compute Flow Directions and Accumulations tab. Alright, so we're going to have it compute topaz, and compute topaz is that process I briefly described in class on Monday, where every cell is analyzed relative, every elevation cell is analyzed relative to the adjacent elevation cells, and the computer is asking the question, if a raindrop fell in this particular elevation spot, which direction would it drain to? And it's doing that analysis for every, this elevation map is essentially a grid with the elevation defined at every location. And when you move your cursor around on that grid, down in the lower left part of the screen, you can see that there's the coordinates and the elevation. And so Compute Topaz, if you click that, it's running through processing to identify. So when you click close, it writes where all of the streams are. And so those are the low points in the map where it projects that there's going to be flow accumulation, and you can change the accumulation threshold. Right now I've got it set to 5 acres, but you can see what it does if you change it to 25 acres and click apply. It's going to reduce the number of blue lines we see, because the blue lines, those flow accumulation cells, are only put into a spot where there's at least 25 acres of upstream area contributing to flow. So the thing that is good is it's assuming that there is going to be a creek where we know that there is a creek. According to our street map, and all of the topographic map as well said that there was a creek going along Payden Fork Road, and if you drove out there, you'd see the creek with your eyes. And so it makes sense that there is a creek there, because that's a low point in the elevation where there's a lot of upstream contributing area, and so the water has to flow towards that location. Now, what the program does in rivers is, it's not so good at calculating where the stream might be in really flat land. So in a floodplain, like in the city area and in the Ohio River itself, it will kind of draw some of these blue lines, but you can't make too much of what those actually are, because in a flat spot, it's not as accurate as in locations that have a lot of elevation, because it just doesn't have the same elevation differences to do that comparison of adjacent cells. So click on Next and create outlet point. Now this is a really tricky spot here, because if you put the outlet point in the wrong place, you kind of have to start over from scratch. And so at this point, we don't want to start over from scratch, so click on Save, just to make sure that if you make a mistake or if the program crashes, you have your model saved up to this point. So you can just either click the save icon or go File, Save, or you could do Save As and like name what part of this demo you're in. So if you did Save As, and you could say Payden, and we did Topaz. So we kind of, that gives me an idea about what point in the modeling process I'd saved this. Alright, so now create outlet point, click that button, and then we're moving the mouse onto the screen, and you can't see my cursor, but we're going to zoom in, and I'm going to put the target just right on that blue cell that is just upstream of the road. So I click, and you notice that there's a little red dot there. That little red dot is an outlet that basically tells the program that's the point that I'm interested in knowing how much area is contributing upstream. So you're going to click Create Outlet Point and then drop it. It has to be on the blue line. If it's not on the blue line, then you're going to get an error message later on. And that's, you can select it and delete it, but historically that's been something that once you create an outlet point, it's really difficult to get rid of it and all of the other things that are associated with it. So that's why I gave you that note that you really ought to save your work in case it crashes. So did everybody create an outlet point at our location of interest? Nick says yes, thank you. It's always good to hear the yes. It's like seeing the nodding heads in the classroom. Austin Linville is a yes. All right. Jeff says, can we move the outlet point? No. You have very little flexibility. Thank you, James. Very little flexibility once you create the outlet. So if it's in the wrong spot, right now you could select it and delete it. But once we delineate the watershed, then it's kind of baked into all the other files and it's a real nuisance to get rid of. So you want to make sure it's in the right spot and verify that you've dropped it on one of those blue lines before you do the next thing. So click on next. Now delineate watershed. When you click that, it's going to calculate, and you see some red text at the bottom of the screen that it's computing the distances and so on. All right, so area 648 acres. I'm interested to know, depending on if you dropped your outlet a little further upstream or a little further downstream, your value may be slightly different from what mine says. Now you could change, mine set it in acres. It's possible that your area for the watershed was reported in a different unit system, and you can adjust what units are reported with this units tab, which is above the delineate watershed. So did everybody get a watershed area that's kind of in the neighborhood of about 650 acres for this Paden city? Yes, yes, good. Jeffrey's still waiting. Okay. So the question that we had in this activity is, what's the upstream contributing area? And at 600, no, Jeffrey, you don't need to select the area. If you've created the outlet point, then it'll automatically delineate the watershed once you click delineate watershed. So let me just show you what would happen if we had not downloaded all the DEM data that we need. All right, I think Jeffrey's got it now. So save your project. So click save just to have it as a reference. Now just watch my screen. Don't try and follow along, but just watch, because I want to show you so that you are able to recognize a common issue that occurs. So let's say I'm starting from scratch. I start the wizard and I'm going to create a new one. I'm going to call this one zoomed in to close. And you'll see what I mean by that in just a minute here. So I'm zoomed in too close. So next, I'm going to define my boundary. What if, when I was creating my project area, I didn't have all the area I needed? What if I was just only zoomed in here? So before, we had this much data downloaded, but what does the program do if I've got the crossing but not the whole watershed? So I'm going to click OK, and so my boundaries have been adjusted. Like when I moved the window, when I panned, it changed the coordinates that were there before. Okay, so these coordinates are slightly different this time than they were in what you did. So next, this time I'm just only going to get the I'll get the street map and the elevation data. So I'm going to click download data from web, use the suggested rescaling values that it has, and you can see it's downloading those down in the lower left. It's reporting the progress, and we've got it. So I'm going to close that. I don't need this heat map. I do want to see the topo. Okay, I'm going to run topaz again, bring up the wizard, compute flow direction. So that's compute topaz. Okay, close. And I have my same stream as I did before. Here it is. Here's the stream. And I'm going to drop my outlet point. You know, the topo map's not my favorite. I'm going to turn the topo map off and look at the street map. That's better, right? All right, so I'm going to drop the outlet. So this is the same thing we did before. But now when I click on Delineate Watershed, I'm going to get a really strange artifact across the top of my watershed. And it's a key indicator that you've zoomed in too close and you don't have all the data you need. So let me close this so that you can see it. You see that straight line across the top, that horizontal line? That's just a dead giveaway that you don't have all of the data in the watershed. That, you know, it's not natural that a watershed boundary would be that straight. And so that means, oh, I have to start over from scratch because I was zoomed in too close and I didn't get the whole watershed. So I have to like basically just throw this out because it thinks the watershed is 421 acres, and it's not because that's the actual size of the watershed. It's because I wasn't zoomed in, I was zoomed in too close, and I need to kind of expand my view, back out a little bit, and get more of the data. So if this ever happens to you, where you see all of a sudden there's just like this long continuous straight line, then what you need to do is start from scratch and redelineate the watershed in another spot. Okay, so let's move on to our second location for today. And the second location that we're going to do is Darnell Road in Huntington, West Virginia. Okay, so you've saved your file, create a new model, so click on New, and then let's do the wizard again. Let's create a file name. I'm going to call this Darnell Class Demo, and save, and then I have to click the Save button so that it actually creates the watershed model and it knows where all of the associated files are going to go. You know, really, it's maybe better if I create a different folder for each of them. So I'm going to create a folder because it's going to be downloading all sorts of like elevation data and mapping files, and so it's best if each project is in its own folder. So alright, Darnell Demo. Save. Alright, so we've created the file name. Next, now we need to go to the right spot. And it remembers the last place that you worked, so when you click on that, it's just going to bring up Paden City because that's the last place we were. So now I'm going to type in Huntington, West Virginia, and jump to Huntington, West Virginia. Now, Darnell Road. You've probably never been there before. In fact, I've never been there before, even though I've been using it as a modeling example for a long time. So let's try and figure out Darnell Road, Huntington, West Virginia, just to get a sense for about where it is. Okay, so I see some things I know. I know where the Jolly Pirate Donut is. I know where the river is, Motel 6, Altizer. So it's kind of in the region here. And you see this Russell Creek. What we want to do is we want to find out how big is Russell Creek. It seems that it goes underneath the interstate. If we were going to be building a culvert, then how big would that culvert need to be to accommodate Russell Creek as it goes under Interstate 64? So I have an idea of my project location. So now here, the trick is trying to find that same thing on this map. If you pan to the side, one of the good ways to look for locations is look at the curvature of the interstate. So here's this cloverleaf on-ramps and off-ramps, the I-64 interchange, and I can find that here. So if I toggle back and forth between Google Maps, and so I'm looking for Russell Creek going under Interstate 64. Here's Russell Creek, I've got it, and I want to make sure that I have the entire contributing watershed. And sometimes that's an iterative process. You don't necessarily know. That first view we were doing with Payden, that was pretty easy to see when we had the whole thing. But Russell Creek, I know at the very least I need to extend so that I see all of the blue line. So I don't have it all now, because if the blue line is still going off the screen, then that means I don't have the entire contributing watershed. I bet there's a pretty good chance that we've got it all at this point. So make it so that your view has approximately the same thing as mine, and it's okay if it's a little to the left, a little to the right, but what we want to see is Russell Creek and potentially all of its contributing area that's going down underneath the interstate. So when you click OK, then it puts those coordinates in. And then click Next, and it remembers that in the past you used web services, and so that tick box should be enabled this time as well. And let's get the street map and the elevation data. So click Download Data from Web, and just click OK on the suggested raster scaling in both cases. So it's getting the street map. You can see down at the lower left in red there that it's downloading the street map. Now it's going to get the elevation data. Now it's suggesting that each cell should be 15 meters in size. If I told it, no, I want higher resolution data than that, zoom level 14 would take longer to download all the elevation data, but each elevation cell would be smaller in size. So you can think of it as like more resolution. It's like taking a picture. Do you want to take a picture at 20 megapixel or at 3 megapixel? So the higher the zoom level, the smaller each of the elevation cells is going to be. So I'm going to stick with the suggested zoom level 13, which was a 15 meter resolution. I believe that was what it suggested. I'll click OK, and it goes and downloads that, and then you can see that we have the data in the background. So I'm going to close this, and I find the heat map a little bit unhelpful, especially when it covers up the street map that I'd like in the background. Let's open up the wizard again, and we need it to compute topaz. So click over here. You can just skip through by doing next, 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 next. All right, compute topaz. Now this may take a little bit longer than the first time because we have more area, but normal program termination was pretty quick on this machine. It takes longer the higher the resolution. So if we had gone for the 3.7 meter cell size, then it would take longer for it to compute topaz. So when I click close, then it's going to load those flow accumulations, and what I'm interested in is Russell Creek going under the freeway. So it puts it in a slightly different place than where it's shown on the street map. And you know, creeks get moved around sometimes by construction, and so it's clearly this is the watershed that I am interested in, even though it's not going under the freeway in exactly the same spot that the program expects. But I'm going to click Next, create outlet point, and I want to include both sides of that watershed. And so I'm going to go downstream of where they come together. So I'm going to make sure that I'm setting my outlet downstream of where the two branches come together. Click Next, and then delineate watershed. And this is the moment of truth to see if I was zoomed in at the right level or if I'm going to have that flat thing. It looks like I've got it. So this watershed is about 1,100 acres. All right. So we've gone through this process of identifying a crossing on a map, setting up the project area in WMS, and obtaining the elevation data and the mapping data. Now let's save it. Brandy couldn't see where I placed the outlet. What I did is I put the outlet, you see how there's these two branches coming together? It just needs to be downstream of that. So it could have been in this cell, it could have been in this cell, but it just needs to be downstream of where those two pieces come together. Otherwise, if I had done it upstream of that, then I would have missed this western branch. All right, we're out of time. It's 9:50, but with this activity that we've done, I think that you'll be able to begin on the homework. In the homework, you're going to be submitting that just by doing screenshots along the way. So take a screenshot of your project area, take a screenshot of, when you were going through the process of identifying which area is going to download. Just basically a step-by-step that proves that you did this same procedure on one of the watersheds that I identify in the handout, or I give you the flexibility to choose a watershed that's of local interest to you. So it could be some watershed in your neck of the woods, whatever you prefer. So have a look at that assignment. We'll continue talking about WMS in class on Friday. If you had any problems with your computer, then send me a message after class and we can set up like a Zoom meeting where I can look at your screen. You can share your screen with me and I'll try and give you suggestions, or we'll talk through the issues together. But hopefully this was a useful activity for you. Thank you for your persistence and your good cheer and doing your best. I really appreciate it. It helps out a lot to have effective students who are working hard. I feel very lucky at this point to have each of you in the class. So have a great day and let me know if you have any questions or problems. I'll see you on Friday.